Squaring and rooting. We're talking about inverses today. Okay? So solve equation for x. Remember that these equations usually have two solutions. So we're going to subtract 21 from both sides. We get x squared equals 49. When I take the square root of both sides, what do I get? Plus or minus 7. Is that two solutions? What are the two solutions? Positive 7 and negative 7, right? Okay. What about b? What do I do first on b? Add 12 to both sides. 4x squared equals 25. And I divide both sides by 4. I get x squared equals 25 fourths. And then when I square root both sides, I get plus or minus 5 over 2. Do you see why I didn't do the division there? Why I didn't figure out it's 6 point blah 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 blah? Right? Yeah, it's a square over square. Okay, so I just left it there because I knew I was going to square root both sides. Okay? What about c? What do I do first on c? Minus 4 on both sides. X minus 3 squared equals 36. Now what? Nope. Nope. Square root. How is this any different than being x squared equals 36? Wouldn't I square root both sides? It's just that something is in here being squared. I still got to get rid of the square root, and that's the only way, the squared. That's the only way I can get rid of a squared is by taking the square root. So I get x minus 3 equals plus or minus 6. Then when I add 3, what is 6 plus 3? 9. What is negative 6 plus 3? Negative 3. You with me so far? No? Oh, okay. Sorry. Okay. So, let's remember about quadratic functions. Okay? Remember, a lot of times when we remember something, it's because we're going to use that knowledge in the next part. You remember that? So, I mean, because really, when's the last time we worked on quadratic functions? Like 3 days ago? 2 days ago? Something like that? Okay? So if this is the table for quadratics, I need to fill in my y values, don't I? So what's negative 3 squared? 9. What is negative 2 squared? 4. What is negative 1 squared? 0 squared? 1 squared? 2? 3? Now plot those points on this graph over here. Whoops. 1, 2, 3, 4, 5, 9. Whoops. Is that what yours look like? If the domain of the equation is negative 3, negative 2, negative 1, 0, 1, 2, and 3, then what is the range? Zero, 1, 4, 9. Why is it 0, 1, 4, 9? First of all, it's least to greatest. Second of all, I don't repeat stuff that's repeated, right? Okay? Is this equation a function? Yes, y. No, x's repeat. Wait, you said it different. How did you say it? X's don't repeat? Is that okay? Is it okay that I wrote this? Could I have written x's don't repeat? Yeah? Okay. Sorry, I try to write what you say, give value to your words. Sometimes you guys make more sense than I do. I mean, I just had 6 starbursts last period. You don't know. They were good. How do we find an inverse of a function? switch the x and the y. Do you remember that, or did you read it? Some of you remembered, some of you read it. Fair enough. Okay? If this is what my table looks like, what do I fill in? Can you see that the x's and the y's switched? So what goes here is 9410149. Correct? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3, 4. 1, 2. 1, 1. 0, 0. Any questions so far? Okay, so is this a function? No. Why do you say that? Oh, x's repeat. What's another way you can say it? Very good. It does not pass the vertical line test, right? Okay. So if we find the inverse of a table by switching x and y, and if we find an inverse of a graph by switching x and y, how do you think we're going to find the inverse with algebra? Oh my gosh, switch x and y. So that means x is here and y is here. So x equals y squared. Okay? Now, a lot of you learned from your Desmos projects that you can totally enter x equals y squared into their calculator, and then what happens? It's still a parabola, it just opens like this, right? Okay? So if we switch x and y here, and then we solve for y, what happens? If I get y by itself, how do I do that? Square root it. Square root, square root. So y equals the square root of x. In function notation, that would be the inverse f of negative 1 of x of the square root of x. Okay? Whoa. Use a calculator to help you sketch the graph of this inverse equation in the box below. So in your calculator, put in y equals the square root of x. Hayden, can I see it? Thank you. This is what he got. Is that right? It doesn't look right. I switched x and y and got a graph like this. I switched x and y and got a graph like this. Do the graphs match? Do they graph? Do they match? No. Why don't they match? There's no bottom half. Will that work? Sometimes we need the mathy answer, sometimes we just need to talk in English. Thank you. Fair enough? So did I do something wrong, or did he do something wrong? No? Okay. These two relations are inverses of each other. We know that because we just found them, right? What are the properties of inverses? Their graphs are blank over the line blank. Reflected. God bless you. Over the line y equals x. God bless you again. If you sneeze again, I'm going to say, get it under control. Okay. Their equations have the blank switched. X and y. So on this side, the graph looks like this. Its equation is y equals x squared, and it is a It is a vertical parabola. Why is it a vertical parabola? Opens up or down, right? Up or down, okay? Well, on this side, what does it look like? Like that? What is its equation? X equals y squared. And what is its shape? Horizontal parabola. Oops. So what is the problem with this graph? This graph is not a function. With an exclamation point, I may add. Okay? So normally, we just graph the top half and call it the... Okay, so here's the deal. We are older than 5, most of us, but this is what the answer key says. See how there's 2 blanks? Square root function. We should be calling it the radical function. Absolutely right. Because that's the more grown-up word to call it. Or something like that. You really need to know both words. I agree that this says y equals the square root of x, but we could also talk about the cube root of x or the fifth root of x or something like that. Okay? Those are radical functions. So specifically this function right here is a square root function, but just kind of keep this in the back of your mind as well. Fair enough? Okay? So it has the table right here. Let's graph those points really quickly. And then we've got to talk about the domain and range. So as you're graphing them, as you're getting done graphing them, start thinking about the domain and the range, please. Anybody tell me anything about the domain? Well, one of those is right. X is greater than or equal to 0. Because we say, how far to the left does this go? Well, it stops at 0, right? And then how far to the right does it go? All the way. So it's everything greater than or equal to 0. What's the other way I need you to be able to write this? Excellent. But it says you can only use blank values for blank. Very good. Positive values for x. So what about the range? What do you know about the range? Y is greater than or equal to 0. It's okay. Last period says half square, 0, comma, infinity, half circle. They remember it. They remember it. It works for them. As long as they know the real words, I'm okay with it. And they do. I think sometimes they like to be a tad bit silly. But then again, so do you. What's this one? You will only get blank answers for blank. So before we go on, why are those two phrased differently? Yeah, you can only put in values for your domain, and you only get out values from your y, right? In this case, if you put positive values for x, which is all you can do, you're only ever going to get positive values out for y. Fair enough? Okay, just want to make sure you understand the language. So again, remember how we used our knowledge of quadratic functions and we use that in the next couple questions? Let's review our quadratic transformations. So this is the equation right here. Fill in the table for me. Done, and I went slow on purpose. If you're just now entering stuff into your calculator, you probably shouldn't have done that for this problem. You can do all of this in your head. Yes? Negative 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. Negative 1 squared is 1 times 2 is 2. 2 minus 2 is 0. Yes? Okay, plot these points, please. This graph is a transformation of the parent function y equals x squared. Tell how each constant in the equation changes the graph of the parent function. What effect does the negative 2 have on the graph? Vertical shift down 2. Please remember your F's. They are important. What effect does the 2 coefficient have? Vertical stretch by a factor of 2. Excellent. Inverse with coordinates. Again, recall that an inverse can be formed by, again, what is it? How's an inverse formed? Switching x and y, and then solving for y, right? In this case, we're just switching values on a table. These x values came over to be the y's, so we need to take the y's and bring them over here to be the x's, right? So 6, 0, negative 2, 0, 6. So plot those points on the graph that's given. Say again? All we did is switch x and y, because that's what it told us to do. You'll see in just a second. Is the inverse a function? Why? X's repeat. See, these x's are the same, these x's are the same. If I went out further in both directions, more x's would be the same, wouldn't they? Okay? How are we going to find the inverse if we're doing it by algebraically? That didn't even make sense. How are we going to do if we're trying to solve this algebraically? We still switch the x and y, right? So x equals 2y squared minus 2. What do I do first? So what do I do first? Add 2 to both sides. X plus 2 equals 2y squared. Divide both sides by 2. Are we going to leave it like that, or do you want me to actually divide by 2? Number 1, does it matter? No. So what do you want me to do? Leave it? Okay. So I get y squared equals x plus 2 over 2. If some of you went ahead and divided it out, it would be 1/2 x plus 1. You notice that, right? Okay. How do I solve for y now? Square root both sides. Square root both sides. Y equals the square root of x plus 2 over 2. What would that look like in function notation? Sorry, let me move it up. Does that make sense? Inverse. So I'm only really surprised about one thing. Not one time when I've taken the square root of both sides has anyone said, shouldn't it be plus or minus? In the last couple times we've done square root stuff, what have I browbeaten you with? You got to have a plus or minus, right? So why have I not put the plus or minus? Am I just forgetting? Let's do B, and I think hopefully you'll see. Use the calculator to sketch the graph. Pretend my graph is straight. Thank you. So it looks like that, right? Does this match our answer from number 5? Clearly it does not. Okay? I feel comfortable saying clearly it does not because remember how I told you about sometimes when people say it's obvious when it's not obvious to anybody in the room except for them, right? How am I comfortable saying this is clearly no? The answer is clearly no. Does it match the answer? They don't look the same, do they? Okay? Why is it okay that I only have the top half here? That makes it a function. That's absolutely right. Okay? That's why we can write it in function notation. If I had plus or minus right here, that would not be a function, would it? Okay? While this is a parabola that opens sideways, a horizontal parabola, it is not a function. This square root function is a function because it passes the vertical line test and because no x's repeat. Okay? So does this graph match your answer from number 5? No, it does not. It's only the top. But that's okay now, right? Now, if I ask you to take the square root of 25, what are you going to tell me? Plus or minus 5, because that's what the answer actually is, right? But if we're talking about using the inverse properties to find the inverse of a quadratic, if we're trying to find functions specifically, you know we have to only take the positive, otherwise it's not a function. Could we only take the negative? That's something to think about, isn't it? Okay? So you are responsible for 7, 8, and 9. Are there any questions on what you're going to do on 7, 8, and 9? Everybody okay with that? Peace.